Well, welcome back. You can count your blessings that this video quiz I'm about to give you is not real. This video quiz I used to give to my students on the very last day of class. As you can see, some of the problems are rather complicated, but we'll go through them together anyway. I will send you all the answers to this video quiz so that you will be able to keep them in your library of things to go over to get ready for my final. And so without any further ado, let's go right ahead and get this going, okay? So here we go. This used to be called Big Quiz number 3, and it was a video quiz that we did on the Turning Point clickers. It was worth 100 points. It was 30 questions, 3 points per question, which of course is 90 points, but a 10-point gift. And then you had to log into your clicker and away we went. So here we go, let's give this thing a try, okay? And you will, as I said, get the answers for this quiz so that you are able to use it to go over and review for the final. So here we go. When attempting to disprove a mathematical concept or law you feel is false, you show that not a single case works for the law, or you show a single counterexample, thus disproving the assumed mathematical principle. Well, I think you know that the counterexample is the idea here, and that is the correct answer, choice B. Which statement below is true about this platonic solid shown to the right? Does it have 5 edges per face and emit 3 edges from each vertex? Does it have 3 edges per face, and does it emit 5 edges from each vertex? Does it have a total of 6 faces? Or does it have 4 faces and 4 vertices? Well, you know, C and D are out of the question. And of course, you can tell, I'm sure, that the correct answer is what? Choice A, right? It has 5 edges per face, and it emits 3 edges per each vertex. Number 3, which statement is false? Well, if you look at A, when 2 to the 15th is evaluated, it equals 32,768. If a certain object is 32,768 sheets of paper tall, then a single sheet of paper must be folded 15 times to have the same height. That's a true statement, right? Exponential growth, showing that every time you fold a piece of paper, you double its thickness, and you have to use a power of 2 to determine the number of layers you would have. The work shown below is a correct example. This is B now, displaying the dimensional analysis conversion method. If I have an object that's 320 inches tall, and I know 500 sheets of paper are 2 inches thick, then I would know that 800,000 sheets of paper tall this object would be. Well, if you cancel 2 into 320, that's 160, and if you multiply that times 500, you will get 80,000 sheets tall. So that appears to be correct. If the largest square of a golden rectangle is removed from one end of that rectangle, the remaining rectangle is also a golden rectangle. Now, of course, you know that's true. There are 4 platonic or regular polyhedrons? No, that's not true. There are 5. So the incorrect answer, the statement that is false, is D. Which set of numbers contains members that are not rational numbers? Well, the natural numbers are rational, all of them. The integers are examples of rational numbers because you can stick them all over 1. The whole numbers, D there, are all rational numbers because you can place them over 1. But none of the irrational numbers are rational. So the set that is not containing rational numbers would be the irrational numbers. Which of the following statements is true? The golden ratio is equal to 1 plus radical 5 all over 5. The set of natural numbers contains numbers that are negative. Pi is a rational number. Pi is an irrational number. And the last one shown there, the last number, 0.13113, followed by a 3, 4 ones followed by a 3, and so forth, is a rational number. Well, statement E is definitely out of the question. It's irrational. Pi is an irrational number. That is true. Pi is a rational number is not true. The set of natural numbers contain numbers that are negative. No, you didn't learn to count with negative numbers. So that isn't true. And of course, A isn't true. So the correct true statement here is that pi is an irrational number. Let's go to question 6, which is not a point that needs to be included in an explanation of why one can expect that in a room filled with 35 adults, 2 people present will be born on the same day of the month. In other words, the 17th or the 23rd. Well, how about pigeonhole principle? That's correct point, isn't it? Will duplication have to occur if you have 35 adults in a room? There's only 31 days in a month. The longest month could only be 31 days. So what has to happen? Duplication has to occur, right? State that if the first 31 people questioned all have different birth dates, the 32nd person questioned must share a birthday with somebody else present, right? That's the pigeonhole principle, the duplication idea. Look at D. No 2 people chosen in the room could be born in the same minute. How many minutes old are you in a particular month if you're born on the 25th? Well, obviously there are too many minutes in a month, all right, to have this situation be able to be said. No 2 people chosen in the room could be born in the same minute. Well, they could be, but this has nothing to do with the setup of the pigeonhole principle. So the point not to be made is point D. 7, which material that follows does not deal at all with the golden ratio? Phi. Fibonacci's do, right? As you get further out in them, they are what? They divide out, consecutive ones divide, larger by smaller to give you phi. Golden rectangle has to do with the golden ratio. The rule of Pythagoras? I don't think so. Various artwork of both ancient and modern artists do show the golden ratio in it. The set 6, 3, 9, 12, 21, 33, 54, 87. That is a growing sequence similar to the Fibonacci's. If you divide consecutive numbers as you get further out into the set, you will find that they will divide to give you phi, larger divided by smaller. Seed pods, spiral counts of various flowers in nature, we found that those were how we generated the Fibonacci numbers in the first place, which of course led us to the result of the concept of phi. So the correct number that does not deal at all with the golden ratio would be the rule of Pythagoras. 8. If QXWM is a golden rectangle, then which statement is false? If you take QM and you divide it by AQ, would you get phi? Yeah, you would, because that small rectangle is a golden rectangle. Its length divided by the width should give us phi. Is MB equal to AB in this figure? Yes, it is. They are both radii of the arc that runs from A to M. So that is a true statement. Is QAFM a golden rectangle? Sure it is, because the 10 by 10 by 10 by 10 square removed from the large golden rectangle would leave a golden rectangle left over. Is phi the same thing as qx divided by qm? It most certainly is. Okay, qx is the top segment of the large golden rectangle, divided by qm should give us phi. I'm not sure if you can see that x, but it's up there. Okay, so I figured I'd let you know that the one that's near my picture up there is the point x. Is AFB a golden rectangle? It most certainly is. Remember, in a golden rectangle, if you have one leg twice the length of the other, and it is a right triangle, you do have what's called a golden rectangle. Okay, so don't forget that. All right, is QAFM not a golden rectangle? No, that's false, as we can see. So the false statement is F. 9. Which pair of sets displays the same number of members? So I've got the word same in there twice. Sorry about that. So which of those sets have the same size? Same number of members in them. Well, I think you can see that the answer to that is N and Q. They both have 3 members, okay? Let's go to 10. If the line segments shown below are golden sections, then does CD divided by AB have to give you phi? You betcha. Does EF divided by CD have to give you phi? You betcha. Does AB plus CD have to equal the length of EF? Absolutely. So it is choice D. The statements A, B, and C are all true. Properties, the 3 properties you need to know to say that you have golden sections. Which matching is correct for naming the regular polyhedrons? Well, if you're concerned about this or you're not sure about this, you can look at your Platonic fact sheet or the sheet which I believe is called number 7, the extras 7. By the way, I called extras 9 sheet extras 8 a little while ago when I was discussing that weird last table problem, but I think you knew I made an error, so I'm not too worried. Okay. The correct choice here is choice C. Those are all correct, okay, we named for the Platonic solids. 12, which statement is false? The exact value of the golden ratio is given by 1 plus square root of 5 all over 2. Yes, that's not an approximation. That is its exact value. The natural numbers and the even positive whole numbers share the same cardinality. Well, this is very unfair. I have not discussed cardinality with you in this course, but I'm going to tell you right now, they don't have the same cardinality. Cardinality means set size. A golden rectangle is twice as long as it is wide. A golden triangle's shorter leg is half the length of its longer leg. A longer leg. Regular polyhedrons, Platonic solids, have faces which are congruent, identical regular polygons. That's a true statement, you know that. Golden triangle's shorter leg is half the length of its longer leg. That is true. A golden rectangle is twice as long as it is wide. No, no, no. In a golden rectangle, okay, the relationship between the length and the width is phi, not twice. By the way, B, the natural even numbers and the even positive whole numbers do share the same cardinality or size. I said that wrong, but don't worry, you don't have to know that for our final. I by error left that question in there. So B is a true statement. The incorrect statement there is that a golden rectangle is twice as long as it is wide. The line segments shown below are golden sections. Then what must be true? Well, first of all, look at C. Phi has nothing to do with these three segments if they're golden sections. We know better than that. Look at D. Does AB times the length of CD equal EF? Or should it say AB plus CD equals EF? So D's no good. Now, it says in statement E that both statements A and D are true statements. Well, D is not a true statement. So right now, we know that E could not be the answer. All right? All right? So now, is it true that AB multiplied by phi would give us CD? I wonder if that's a true statement. Well, isn't it true if these are golden sections that we should have the following situation? Shouldn't CD divided by AB give us phi? Wait a minute. If I put phi over 1 and I cross multiply here, I get CD is equal to AB times phi. And notice that's what this says. Does CD times phi give you EF? If I take EF and divide it by CD, I should get phi. If I stick that over 1 and cross multiply, does CD times phi have to equal EF due to that cross multiplication? Yeah, it does. That's kind of a tricky question. So this is a true statement. Statement A right there. Okay? So the correct answer to this statement is part A. All right? You would have to think a lot to be able to come up with that answer. And don't worry, I won't give you one that hard on the final. Let's go to 14. Which of the following numbers is irrational? Well, A is a fraction, so it's rational. B is a repeating decimal, 161616 on the end. It's rational. 0.315, 315, 315, forever to infinity is also rational. Notice 78 has a growing pattern. 1, 3, then 2 1s and a 3, then 3 1s and a 3, then 4 1s and a 3, then 5 1s and a 3. That's definitely what? Irrational. E, no way. It's got a fraction in it. And F is a terminating decimal, which makes it rational. So therefore, the correct answer is D. All right. We're halfway there with this question. Which is the correct prime factorization for 3300? Now, you don't actually have to work this out to figure it out. Look at the 4 answers that are there. Are any of those 4 answers showing numbers in them that are not prime? Remember, the prime factorization of a number has to have all primes in its prime factorization. Notice 15 is not prime, or is 55 in A. In B, 15 isn't prime. In C, every single number is prime. And in D, 4 isn't prime. So therefore, the correct answer for that is C. What is the next Fibonacci number after 2584? Well, if 2584 is the 18th Fibonacci number and the 17th Fibonacci number is 1597, remember, all I have to do is add those two together. So I don't know is not the correct answer. B, there's no way to get it. No, there is a way to get it. And what you have to do is add those two numbers together, which I believe will give you the answer 4181. Question 17. If QXWM is a golden rectangle, and the rectangle AFMQ, the little guy, or the second littlest rectangle there, the one to the left, is golden. And if RFMT is the largest square that can come out of AFMQ, what must be true about the rectangle ARTQ? Well, would QA divided by QT, have to give you phi? Is ARTQ also a golden rectangle? If it is statement A right? Can ARTQ not be a golden rectangle? Or are both statements A and B true up there? And in other words, is statement D the correct answer? And I think you can tell that it is. So both of those statements are right. So the correct answer to this problem would be choice D, even though I have marked both A and B up there. But obviously the correct answer would be D. Having listened to today's class discussion, well, not really. Well, we didn't talk about the golden triangle. And if triangle XYZ is such a golden triangle, which statement cannot be applied, used, or is false in relation to this triangle? Well, look at statement A. Would angle X plus angle Y plus angle Z have to add up to 180 degrees? Isn't that true in any triangle? If I were to double the length of A, would I get the hypotenuse C? Wait a minute, look at C. If I doubled A, would I get the length of B if this is a golden triangle? You betcha, I sure would, because in a golden triangle, one leg is twice the length of the other. So 2A should equal B. Let's go back to the statement B. If you double the one leg, will you get the length of the hypotenuse? No, I don't think so. You can get the length of the hypotenuse, however, by doing what? By using the rule D, A squared plus B squared equals C squared. So do all these formulas apply? No. The one that doesn't apply is statement B, okay? You can't double the shorter leg and get the length of the hypotenuse. Okay, 19. If QFXM is a golden rectangle, now that is what? The small rectangle on the bottom. And you add that large square ABMQ to it, then is the great big rectangle formed ABXF also a golden rectangle? Is that statement true? Well, you know, we proved in class most certainly that that is true. So it is a true statement. If you add a large square to a golden rectangle, the largest square possible, you will obtain what? Another golden rectangle. And you work the other way. If you take the largest square out of a golden rectangle, the rectangle left over is also golden. Viewing the figure shown and recalling V is the vertices, E is the number of edges, F is the number of faces, which statement below does not apply? Well, if you look at C, D, and E down there, the vertices are correct. There are 14 of them. There are 21 edges on this prism, okay? By the way, what kind of prism is this called? It appears to have 7 sides or edges on the top, okay? So it's a heptagonal prism, okay? But so if we have 21 total, 7 faces on tops, 7 edges on the top, 7 edges on the bottom, and 7 vertical edges, the 21 edges is correct. The faces would be 9, as it says. Okay, so C, D, and E are okay. What's wrong with statement A? It's out of order, right? The Euler characteristic says if you take the vertices and subtract the edges and then add the faces, you will always get 2. So the formula which does not apply is A, because it is not set up correctly. 21, which figure is definitely not a Platonic solid? Well, I think you can see it's B. Which figure below is definitely not a regular polygon? Remember, to be a regular polygon, all the sides have to be what? Exactly identical in length, and all the interior angles must be congruent. So which figure is not a regular polygon? Well, it's obviously what? It's obviously C. That looks like an isosceles triangle. Only 2 sides have the same length. 23. If in a probability experiment the first event has 20 outcomes and is followed by a second event with 10 outcomes, then the 2 events combined have or show how many outcomes? Well, A is not correct. You don't add the number of outcomes together, okay? You do not take 2 to the 30th power to get this answer. This is not an exponential growth problem. You don't take 2 to the 10th and add to it 2 to the 20th to obtain the answer. You multiply the outcomes together, right? But if you multiply 20 times 10, do you get 2,000? No, you do not. You only get 200. So the correct answer is not shown. So the correct answer for this problem is E. 24. In a combination probability experiment, if the first event has a probability of 0.3 of occurring and is followed by a second event with a probability of 0.7 of occurring, then the 2 events combined have a probability of what of occurring? Do I add those probabilities together? Or do I multiply those probabilities together? Well, I think you can see the answer would be 0.3 times 0.7, which is 0.21. Well, wait a minute. Is 0.21, that decimal, the same as 21%? Yes, it is. So therefore, okay, there are 2 correct answers for this problem. They are 0.21 or 21%. So there's a 21% probability that first event followed by the second event will occur. It's a 21% probability of that happening, or 0.21 is a decimal. 25, and if an event in a probability experiment has a 5/18 probability of taking place, then the probability of that event not taking place must be what? Well, if you have the probability of it going to be taking place and you want the direct opposite, you simply subtract from 1, which is choice D. We have subtracted 1 minus 5/18, which of course is 13/18. 26. The probability of rolling a sum when rolling 2 dice simultaneously is what? Well, how many 7s do you see up there on the screen of the 2 dice when you put them together? Well, the diagonal going from the lower left to the upper right all has 7s, doesn't it? 6 and 1s, 5 and 2, 4 and 3, 3 and 4, 2 and 5, 1 and 6. So that is a total of 6 outcomes out of how many? Is it 6 out of 12? Or is it 6 out of 36? And of course, you know the answer is 6 out of 36 would be the probability of rolling a sum of dice which give you 7. Look at 27. Is the statement that follows true or false? Work out this problem by evaluating the left side, then record your answer. Well, let's see. If you take a calculator and you do 4 to the 3rd power, okay, you obtain 64. So if I take 64 and add to it 27, I get a total of 91. Is 91 equal to 3 mod 8? To determine whether it is or not, I divide by the mod number. So I take 8 and I divide it into 91. If I take my calculator and take 91 and divide it by 8, I obtain 11.375. I throw away the decimal part. I take my whole number part, 11, multiply it by 8. That's 88. My remainder is 3. Okay? So it appears that this statement is true. You do get 3 mod 8. So this answer is what? It is true. All right, question 28. Carefully observe the numbers shown here. Which letter choice below is an irrational number which is between them in value? Well, which two can I throw out immediately? I can throw out answer A and answer D because they're irrational numbers. So that won't work. Excuse me, I don't want to throw out A and B. A and B make up possibilities for the answer. I can throw out B and C, right? Because those are rational numbers. So now I got to make sure which one of the two choices, A and D, is between the two numbers. Okay? Well, if you look at A, you can see you get 6, 5. If you look at D, you have 7, 5 partway out through the number. That's too large, right? It's not between them. So if you took the average of the two numbers, that wouldn't work. You would get something between 6 and 7, like 65 or 66 or 68, or you know what I'm saying. But so, and then you would have to put an irrational behavior on there. So the correct answer should be choice what? It should be choice A. 29. Which letter choice below shows an incorrect conversion by the Kelly's cheater method of the given repeating decimal into the fraction it came from? Assume all reduced fractions are correct. Would A be all right? I think so. It's got 6 repeaters in it, right? 6 digits repeating, excuse me. So you put it over 6 9s. Look at B. There are 2 digits repeating, 27, 27, 27. You put it over 2 9s. Notice I have it over what? 3 9s, which is incorrect. Look at C. I have the 315 over 3 9s, so it's okay. All right. So the incorrect conversion would be what? Choice B. And finally, for our last question on this pretend video quiz, if the probability of never rolling a 2 when rolling a single die 20 times is 5/6 raised to the 20th power. First event, there's 5 ways out of 6 not to get a 2. Second event, there's 5 ways out of 6 not to get a 2. Third event, 5 out of 6 not to get a 2. So if you're rolling the dice, rolling the die 20 times, it would be 5/6 multiplied together 20 times, or raised to the 20th power. What would be the probability of rolling a 2 at least once in 20 rolls? So remember, we have to use the opposite, get the opposite answer first, okay? So in other words, we'd have to do 5 6 to the 20th power and take that answer and what? Subtract it from 1. We want the opposite. So if you look at choice B up there, choice B gives you the probability of never rolling a 2 in 20 rolls of a single die, whereas C gives you the probability of rolling at least 1 2 in 20 rolls of a single die. You might get 2 of them, you might get 4 of them, you might get 7 2s in 20 rolls, but you'll at least get 1. So there's a 97.4% chance, or written as a decimal, it's 0.974. So the correct answer is C. Well, we have taken quite a bit of time to take a look at some more ideas, 30 questions involving material you will be asked about on the final exam. Now, I want to caution you that when you take the final, okay, before you take it or print it or put it on your phone or wherever it is you're going to make it be displayed, I want you to follow the directions in the video that I'm going to send with the exam. Pages 1 and 2 are all multiple choice and true-false questions. You will give me back only the answer sheet for pages 1 and 2. So you've got to take a good, crisp picture of the answer sheet for pages 1 and 2. You do not have to send me back pages 1 and 2, okay? However, pages 3, 4, 5, 6, 7, 8, and 9 all have short answer questions, except for one question, which I believe is problem 38, where I ask you to record your answers to it on the answer sheet you used for page 1 and 2. So there'll be 5 answer blanks for you to record your answer there, because it is a multiple choice question. Okay, I just happened to bury it later in the exam. So that you will also transfer to the answer sheet for pages 1 and 2. But the other pages, 3, 4, 5, 6, 7, 8, and 9, so in other words, 7 pages, you are to take very careful pictures of those pages or scan them. Make sure that I'm able to read what it is you have written on those pages. And for each of you, you need to send me all 7 of those pages, okay? So that I'm able to correctly grade your exam. Now, folks, I have finished all the review that I can do with you for this final. Now it's your turn. You've got the weekend to prepare, okay? All right? Late Monday night, I will send you this exam, all right? And you have until probably Friday if you need it, but at least until Thursday to get the exam done, to get it prepared to send to me, and to send to me, either by email or by text, all right? If I do not have your exam, I will contact you. Make sure you put your name on those sheets, particularly the answer sheet for pages 1 and 2, and the first page of page 3 of the part 2 of the exam. So the exam is actually in 2 parts. It's called part 1 and part 2. Part 1 is worth 60 points, and part 2 is worth 140 points out of the 200 points, which I will divide by 2 to obtain your grade out of 100, okay? Please make sure you put your name at the top of each page so I don't confuse which page belongs to which person, Okay. Now, I didn't leave you name blanks to put your name in. However, I did, on all the pages, but I did on the first page of part 2, and I did on the first page of part 1. So spend some worthwhile time over the weekend getting ready for this final exam, okay? You can expect it to be sent to you Monday night, okay? And once you have received it, go to work, get it done, and get it back to me. It's been a pleasure working with you. I would much rather have worked with you in person, but hey, we've made the best of what we could here. When you're on campus, if you're still going to be around next year, stop in and say hi. I should be teaching in the same room. So I hope that I will get a chance to converse with you further at a different time or at a later time. Best of luck to you all in the exam, and go get them. Take care.